Hi second graders, welcome back to Module 8. Today we are doing Lesson 11. What we're going to be talking about today is how to make parts into wholes. We're going to talk about halves, thirds, and fourths, and how many more halves, or how many more thirds, or how many more fourths that we need to make something whole. Alright, let's start off with some addition. Now, we did this a little while ago, so this is going to be a good review. You may use a place value chart, which is going to look like this. Or you can use vertical addition to solve. Doesn't matter to me, whatever way you're more comfortable, but this is good practice for us. So in between each problem, I'm going to have you pause and try it on your own, and then we'll go over it together. So this first one I want you to solve is 112 plus 59. So pause and solve, and then we will do it together. You're adding. Got it? All right, let's do it. I'm going to try vertical. If you did place value, that's perfect. Same idea is going to be the same. We're going to add our ones first. 2 plus 9 is going to give us 11 ones. So we're going to need to bring our 1 down and bring our 10 over here. 1 plus 1 is 2. Plus 5 is 7. And then we just add our hundreds. 100 plus 100 is 200, so you should get 271. Nice job. Try the next one. Pause and solve. 184 plus 135. Come back when you're ready. Got it? Always remember, make sure when you do this, you're lining up your ones, your tens, and your hundreds. Whether it's in a place value chart or vertical method, make sure you are lining them up. So we always start with our ones when we're adding or subtracting. 4 ones plus 5 ones gives us 9 ones. 8 tens plus 3 tens gives us 11 tens, which is 1 10 and 100. And then we're going to have 3 hundreds for a total of 319. Nice job. Next one. Again, try a place value method or a vertical method. Doesn't matter to me. This is just good practice for us because we haven't done this in a while. So go ahead and solve with whatever method works for you, and then we'll go over it. All right. First things first, let's add our ones. 5 ones plus 8 ones gives us 3 ones, 1 10. 8 tens plus 1 10 gives us 9 tens, and then 3 hundreds plus 1 hundreds gives us 400, so we have 493. How you doing? Good job. Let's try another one. Again, vertical method or place value, doesn't matter to me. Pause and solve. Come back when you're ready. Here we go. Let's add our ones first. 8 plus 3 is 11, or 1 10 1 1. So we bring our 1 10 over. 6 tens plus 7 tens is 13 tens. Plus 1 more 10 is 14 tens. So I'm going to bring my 4 tens down, my 100 over. 200 plus 100 plus 100 is going to give us 400. We end up with 441. Nice work. Let's keep going. Let's do 2 more. 589 plus 233. I love how much you guys are getting this and working hard. So pause and solve for this one. Come back when you're ready. All right, let's add our ones first. 9 ones plus 3 ones gives us 12 ones, or 1 10, 2 ones. Bring our 10 over. 8 tens plus 2 tens give us 10 tens, or 100. But we have that 1 more 10 to add in. So we're going to get 110. 100. 100 plus 500 plus 200 gives us 812. Awesome job. One more, I promise. One more practice problem. Pause and solve 471 plus 289. Come back when you're ready. All right, let's add our ones first. 1 plus 9 gives us 110. Bring that 10 over. 7 plus 8 gives us 15, or 15 tens, plus 1 more gives us 16 tens, which is 6 tens and 100. plus 2 plus 4 gives us 700. So we get 760. Awesome work. I am so proud of you guys for remembering how to do this and working hard. Very impressed. All right, let's do our application problem. Whew. Jacob collected 70 baseball cards. He gave half of them to his brother Sammy. How many baseball cards does Jacob have left? That was very nice of him. So there's 70 between both of them now because he gave half away to his brother Sammy. So we need to figure out how we can get 70 split in half. That means equal groups of 70. So in my head, how I would solve this is I know that 30 plus 30 or 3 plus 3 is 60, right? 30 plus 30 is going to give me 60. So each of them could have 30, but we still need 10 more. So what I'm going to do is I'm going to take the 60 plus 10 is going to get us to 70. 10 can be split into 5 plus 5, right? That equals 10. This right here is giving us that 70. So what we're going to need to do now is add and add. And we get 35 for each brother. 35 plus 35 is going to give us 70. Are those two groups equal? Absolutely. So he has 35 baseball cards left because he gave half to his brother Sammy. Very nice brother. All right, here we go. So we're going to compare a whole and then counting halves, thirds, and fourths. So, what do we need to complete this circle? How much more needs to be shaded to complete this circle? So this circle is split in two. 2 means there are 2 halves. Halves 2, right? So how much do we need to finish this circle? We would need 1/2. So 1/2 plus 1/2 equals 1 whole. Remember, half is 2 parts. 1 and 1, going to equal 1 whole. Good. 2 halves equal 1 whole. Say that with me. 2 halves make 1 whole. All right. Now, on this one, we have what? We have thirds. Very good. So how many thirds do we need to complete this whole rectangle? We have 2 thirds. How many thirds do we need to equal the whole rectangle? Very good. We're going to need 1 more third. 1/3 plus 1/3 plus 1/3 is going to equal 1 whole. So say this with me. Ready? 3/3 equals 1 whole. So we have 2 halves equal 1 whole. 3/3 equal 1 whole. Okay? All right. How many fourths do we need to complete this square? Good. We need 1 more fourth. So we have 1/4 plus 1/4 plus 1/4 plus 1/4. 4 fourths equal 1 whole. Say that with me. 4 fourths equal 1 whole. So we have, ready? Repeat it with me. 2 halves equal 1 whole. 3/3 equal 1 whole. 4 fourths equal 1 whole. 2 halves, 3/3, 4 fourths, 1 whole. Whew. All right. How many fourths do we need to finish this square? If there's 1/4 shaded in, how many do we need to finish it? Good. 3 fourths. So we're going to color in 3 more fourths to finish the square. Awesome job. All right. So, how many halves are shaded in on the first problem? Just 1/2. Good. How many halves are shaded in on the second problem? Oops, sorry. 2 halves. Awesome. Which shape shows the full whole? Point to it. Awesome. 2 halves equal 1 whole. That one's fully shaded in. Awesome. How many thirds are shaded in on the first rectangle? 1. How many thirds are shaded in on the second rectangle? 2. Very good. How many thirds are shaded in on the third rectangle? 3. Awesome job. Which shape shows 1 whole shaded in? that green one. Nice work. All right, now we're on to fourths. How many fourths in the first rectangle? Good. How many fourths in the second rectangle? 4. Good, they're trying to trick you. How many fourths in the third rectangle? 2. And how many fourths in the fourth rectangle? 3. Nice job. Now point to the rectangle that shows one hole. 4 fourths equal 1 hole. Very good. All right. In your problem set today, you're going to be working on making one hole with halves, thirds, and fourths.